Don't know. Raining, I think. Oh, then I'm caught in the rain. Is it still raining? Drizzling. Yeah. Yeah.
Hello.
Okay, let's start first. Now, this will be the last part for electricity, basically on practical electricity. Right, yeah, guys, take out your notebooks. Quick revision since there was no lesson last week. Now, take note of this unit. Kilowatt hour is actually a unit for energy. And in fact, I would say almost all the utilities over the world, they make use of this unit to measure energy, how much energy you use in your house or even in your commercial space. Now, mind you, this is obviously not an SI unit. Okay, so this typically cannot be used in any other formula except to calculate the cost of electricity, how much you are paying. Otherwise, you don't use it in other formulas. And in the case of Singapore, typically you'll be given this costing. This is the rate for Singapore, about 20 cents per kilowatt hour. Now, my only reminder to you, please, if you want to calculate how much energy you're using, make sure you get your energy power rating in kilowatts. Hey boys, no running, man. George, no running around. No running, And the other thing, make sure your time is in hour. This is the part that a lot of students will somehow forget and of course make careless mistakes. So double check. Power in kilowatts, time in hours. Now let's go on. We also mentioned some hazards, electrical hazards. Now here I have listed 3, but obviously there could be others. And you notice I mentioned this quite a lot, half of list resistance. That means if you offer the circuit a path of less resistance, it will go through that path, even if it's yourself. Okay? Let's say you yourself, you go and touch something and you have less resistance than the normal circuit, then basically the current will go through you. Likewise, if somehow water gets into the circuit, water also offers the half of this resistance, so it will go through the watery part, which includes yourself. I mean, if you are the one wet. Okay, now this one is quite common, especially if you're not careful at home. You plug in too many appliances at the same time, and typically the arrangement of the plug will be parallel. If you keep plugging in, normally if you notice, at most, how many can you plug into one socket? Do you all notice? One socket, how many appliances can you plug in? If you take the adapter, I mean. How many does the adapter allow you to plug in? Never try. About 3, yeah? About there. Because the more you plug in, I don't know whether you realize, the total resistance becomes lower. Now, come, let's look at the basics again. I hope you remember this. Now, remember if I have this circuit, folks. All right, then what if I add in another appliance? One more. Oh, you may not realize this, the more appliances you have, the total, the resistance becomes lower. Total resistance becomes lower. Now, even though each of them may have the same resistance, but the total actually goes down, no? You try calculating, you try it, okay? And what does that mean? It means, remember my EMF is constant. It means my current will increases. Okay, that is the implication. The more parallel branches you have, the total resistance becomes lower. Try calculating, you get the same conclusion. And of course, this current becomes larger and larger and larger until the circuit cannot handle the current. That's when you have overheating and fire. Okay, so that is the I would say the theoretical part behind this issue. Okay. Okay, what else? All right, now the other thing that they may ask is this. All right, what kind of protection devices are available? For your syllabus, there are 4. Fuses, circuit breaker, birding, and lastly, double insulation. All right, yeah, please remember this 4. They are well within your syllabus. Okay, important thing for a fuse. I can't remember whether I mentioned it. Fuse. All right, basically, okay, I'll mention it later. For fuses and circuit breakers, okay, I didn't mention it. Maybe you can write it in. Circuit breaker also has a current rating. Okay, circuit breakers, they have a certain current rating. Now, just to give you a realistic figure, for Singapore, the fuse is about 13. For the socket, I mean, for the socket. Circuit breaker also about 13. I'm referring to the socket, not the appliance. Appliance itself, this one, okay, by the way. What I'm saying is this socket, inside the socket, we will have fuse. But inside this plug, there's another fuse. This one is the appliance fuse. Alright, so this one depends on the appliance. The rating may be different, but the socket is usually about 13 within the socket. Okay. Okay. Next time bring your own stapler. Now, same thing for circuit breaker. That last, I think 2 weeks ago, is inside this box. Each circuit breaker will also have a setting, a rating. Alright, so typically about 13. But there is one appliance which is higher than 13 in your home. Anybody know what that is? Or actually maybe two appliances. What are the KV current appliances in your home? I mean, may or may not come up for exam. Of course, if they come up, they'll tell you what it is, but it's always good to know. Why? Which two appliances use a lot of current in your home? We are not talking about industry or factory, it's your home. Okay, basically one is aircon. What's the name of the appliance? It uses high current. Yeah. So what is this? Second one is water heater. If you are using electrical water heater. These are the most basic. Do not draw vertical lines. Okay, so usually heating and cooling, they use a lot of energy. So aircon and water heater. And therefore, they have a separate circuit breaker. All right, the circuit breaker is rated differently. I mean, for info, because if it comes out in the exam, they'll tell you something like that. They'll give you the background story first. Just a reminder, this has come up before. Make sure you recognize this. This is a fuse, a symbol for the fuse. Do not confuse with resistor. It's not a resistor, it's a fuse. And it has definitely come up in your exam before. For Singapore, we tend to use this symbol. Okay, now the other one that comes up often is earning. And to understand, you have to look at this circuit. Right, I think I drew this last 2 weeks ago. Right, so essentially, your 1, 2, and 3. Now, I think I showed you last time the plug. All right, this is the plug, and why are there 3 pins? Earth, live, and neutral. That is why there are also 3 holes in the plug. Here, I hope you realize that there's one socket behind, right? I think you can see. All right, it has 3 holes as well. It corresponds to this Earth, life, and now let's look at the appliance. So essentially, your appliance is joined like that. Alright, give me a moment. I give you a map. Okay, I want a vertical. Vertical. What does it mean? What does vertical mean? Yugandra, are you there?
Yes.
Yes, huh? Okay.
Yes.
All right, we are just doing some reinforcements of previous subject matter.
Okay.
The polar opposite, right? Just be 90 degrees. Now, as I said, this, let's say these 2 wires, they are within the larger wire here. This side. Come, guys. All right, they are within here. That's why you don't see 2 separate wires. They are all wrapped within the outer casing. But as I said, notice there are only 2, right? Because this one only has live and neutral. There's no earth. The reason is, yeah, what's the reason? How come only live and neutral? I'll pick one. Come, Bernice, what's the color for live? Live wire, what's the standard color? It's the same all over the world. Yes, brown. Pick one. What's the color for neutral? Blue. Remember, maybe for your exam, but in real life, you get it wrong, you can get killed. Okay. So there's no earth. Why? How come this has no earth inside? Yeah, okay. Basically, yeah, the voltage and the current are very low. So this is a small appliance. Of course, I removed the appliance already. But basically, the appliance, I can't remember what it is. It's a small one. So there's no need for an earth. But there's a second reason. How come there's no earth? Yeah, small appliance, small current, small voltage, but also remember just now I mentioned something. Right? What does the
Teacher.
appliance have?
Teacher.
Yes, Jimendra.
For the 3-pin plug, how come there's a earth wire?
Yes, I'm getting to that. Okay, now
Because
guys, if it's a
my-
small appliance, typically it has double insulation. Usually, like this one, this thing here, projector. Okay, this one has double insulation, even though you can't see it. Outer casing is plastic. There's an inner casing which is plastic also. Alright, so there's no need for earth because it has double insulation. Okay. Take note of these 2 reasons. Now, Shivendra, to answer your question, There are some appliances like this one. Okay, let me draw in. Okay, this has an earth too. So for this case, it has 3 wires. But of course, you don't see 3 separate wires. They are still within the same casing itself. Okay, and normally those that have earth wire, 2 reasons. Maybe you want to jot down. Okay, earth is present. Okay, first reason. It has a metal body.
Okay, I will demonstrate a very simple one. Teach you the basics of paradigm.
Like for example, washing machine.
Okay, so example, right? With this, I want the exact same thing. Image. Just for me. I do everything.
That means if you touch it, yes, possibility of current going through you, through the metal body. Okay, second, as Bernice mentioned, just now was low voltage, low current, but a big appliance is likely to have high voltage and current. In other words, it presents a larger electrical hazard. Maybe I shouldn't use the word larger, greater.
I align it together with mine, so it becomes one. Then I take the second rule, don't put it at the bottom.
So that's why you need the earth for protection. Okay, so look out for this. All right. And of course, it goes without saying, your air conditioner, definitely you need the earth. High current, I already mentioned it. High current, high voltage also. And it has a metal body. Okay, but as I mentioned lastly, just be very clear. These 3 wires are all wrapped up within a casing. All right, so you normally can't see the 3 individual wires unless you open up the casing or you open up the wire insulation. Okay, let me see. Any questions? Now, just a repetition. Why do you need 3? Live, neutral, earth. Now, basically, your live carries a voltage. And if you join up the appliance, current will flow from the live to the neutral. Okay, so as to close the circuit.
And I give you a horizontal,
Same here. From the live, current flows through the appliance and it returns to the neutral. Guys, take note. The earth has no current. Under normal operation, the earth has no current. Unless there's a leakage. Oh, of course, there's a bad news. Unless there's a leakage of current. Okay, so take note. Under normal operation, no current flows in the earth. Okay, but why is there a leakage of current? I don't have an appliance to show you, but imagine Yeah, this one doesn't work so well. But imagine this is a flyer, metal casing. Alright, then this one plugs to the flyer. Now, for some reason, if let's say, I hope you can notice the brown one. Can you see that the brown wire? That's the live. If for some reason the live somehow contacts the casing, usually it means a loose wire. Alright. Somehow the live touches the casing. Guess what? Now the whole electrical box, I mean the whole casing is also live. And you go and touch it, then current will just go through you. Okay, so that is one example of current leakage. Where it's going to where it's not supposed to go to. Maybe you can try to localize it. Essentially, the live wire comes loose and touches the metal casing. See, that is when you have a leakage of current. Okay, maybe I write down for you as well. Oh, of course, this has been asked before. Why is there a leakage of current? But there are other possibilities, like water somehow goes into the appliance. Okay, questions, anyone? Okay, one more important thing. Now, look at the socket. I hope you notice, look at the socket there, this one. There's a switch, right? Correct. Every socket has a switch. Unless your socket is very specialized. Now, important, the switch, let me just draw it on the diagram. Is here. Now, essentially, the switch is always on the live wire. Okay, live wire, there's a switch. And of course, this has come up before in the exams. It is never on the neutral. Yeah, why? Why is it on the live and not on the neutral? Remember, the live carries the high voltage. So if you want to switch it off, once you open this switch, the appliance is no longer live, and then you are kind of safe to work on the appliance. All right, basically you want to be sure. Once you open this circuit, that means this is not live. You open this circuit, this is not live. Bernice, okay? Right, remember that. It has come up many times. They'll give you a diagram and they tell you what is wrong with the setup. Sometimes it's because of the switch. Sometimes they put the switch on the neutral, which should not happen. Okay, let me see. Anything else to tell you? Yes, finally. Please remember the colors. Live, neutral, and earth. What else? Can you also jot down? It's not just the switch, but the fuse is also on the live. The circuit breaker is also on the live wire. Okay, take note.
Circles are more easier. And plus, like this circle thing that I make from big circles. It's not.
Now, in other words,
Yeah, but I didn't even know you.
oh, by the way, this is the symbol for circuit breaker, even though you don't remember it. But sometimes they will show this in your exam, in your own circuit diagram. So this is the circuit breaker. But the fuse, yes, make sure you know the symbol for the fuse. Fuse, circuit breaker. So if I go back to my diagram, so what you should do is you should draw one additional thing inside here. There should be a fuse here as well. Of course, it's in series with the switch. One fuse here as well. Now, circuit breaker is seldom on individual appliance, seldom. Circuit breaker is normally at the entrance to your door, to your main door. So for the circuit breaker, I would draw it here.
Wait, this question is it me?
Okay, circuit breaker is normally just one at the main entrance. But for the individual appliance, they will have a switch and a fuse, and probably more than one. Okay, I think that's about it. Any question? Okay, just one last thing. Now, as long as your appliance has double insulation, it has no earth, and vice versa. All right, if your appliance has an earth, it has no double insulation. So they're mutually exclusive. Now, small appliances like this, radio, hair dryer, yeah, they are small. So typically double insulation. Larger ones, TV set, especially the big ones, TV set will have earthing. Air conditioning, as I said, confirm there's earth. Water heater, confirm there's earth. Even your kettle, what do you think? Your kettle has earth or not? Kettle. Yeah, no, I mean, yes, Shivendra.
Oh, nothing.
Okay, now a kettle may not be very big, no doubt, but because it's a heating device, the current is still quite high. And don't forget, some kettles have a metal body. Not all, but some of them have a metal body. And have you ever seen double insulation in a kettle? I don't think so. All right, so kettle typically has an earth. Even though the size is small, but its current is pretty high. And it has a metal body. I mean, some of them have it. Okay, let me get you the worksheet. All right, come try to read this. Hi, Shivendra, I'll put the worksheet on the screen.
Oh, okay.
Yeah, Shivendra.
Oh, yes. Okay.
So what if I take the line again? Give you a sample line. Again, the thing I thought. Put the first ruler on the line.
I'll try to get you a soft copy now if I can. All right, you just wait.
Hey, why your first one green? Why you look so funny and look so it's great, it looks so hey. This is
No. I used to love. Why is that so funny?
I'll say to you something. You sure that's when I'm like that looks like diamonds. Wait, just one ruler or two, huh? You use two. Wait, when you don't want to online, you want to be good. Yes, you check out. These don't want better. Oh, you can swear. So these two also will go. Look at this. I don't know what to do. With
No.
yes.
No.
Then yeah. My friend small. Maybe. Here.
I hate therapy tools.
Want to
What?
fully. Fully.
What's so cheating? What?
It won't do.
But
It looks so bad.
it's not bad.
It's not on the line.
It is on the line.
So the color not change it.
It is not too.
No, it's not. What? Why else can you say box square? Yeah, I can compare one. I know it's easier. Box square is okay. You sure it's okay? I see. Let me see like this.
Wait, how am I going to draw a tree here of the square? I'm thinking, oh my god, so easy.
Okay, it's okay.
Get it.
We're in a square.
Get it.
Try.
That's why we did a smiley face. Yeah. What is the millimeters for today?
This one color blue. That's the mini place. Look at the mini place.
Oh, the millimeters. Don't see square. Those for me that's like 3 cm or fingers.
Easy now, because we have. Oh, it goes.
Shivendra, check your WhatsApp.
Okay.
There was an error.
Area.
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 What's the error point with? You don't need to go through. I need you to explain.
It's going to be checked.
Thank you.
Look at the quality. It's not sharp. The bottom is a shut. The corner is
Bro, stop singing. Want me to stop singing or think it was something? What's this?
two. Okay, I want
Oh.
1 3. You can share the corner punch from.
Yeah, because you can't see.
Wait. Wait. You're doing rectangular.
Triangle.
No. You really are. Hey, wait. Before we go on. Always become the more. Like something that you like. Yeah, so even when you go up for sideways, you will come inside. Before you need parts to very easy. How easily you
Bro, what's your phone? What's your phone birthday? What's your phone? Another phone.
What?
Case.
Oh, yeah, we have this.
Oh,
I mean the skin.
see, and this.
Also,
So school. I thought this was.
don't show up. It's always shipping.
You know, keep items, take off my cover and fonts. Because this one is so loose. See, there's something on here. This one in the mid plot that was something. It's recommendation.
No.
No. Even if you want it.
One minor. It's not correct we go, the first one.
Like in minor.
What's square, right?
If I turn another, it looks like something.
Okay. Oh, no, okay. Wait. Why your this one looks so funny? That's all right. You mean that? No, that's a shape you understand. Yes.
How do you draw a table?
Question, Bernice?
Okay.
Yeah, Bernice, question?
Is so basically this one.
This is what? For you, this will be the last chapter. For them, they still have a bit more. 3 what?
Three basic one.
Which are?
Although it is basic, then dash and
V equals to IR also, right? But okay, what?
Yeah.
I didn't even go through any formula today. For today, it's more concepts rather than formulas. Yeah, you want formula? Any particular question you want? Power formula? She hasn't mentioned yet. Oh, it's okay. You got some time.
Oh my, you know what?
How many?
1, 2,
Now draw the other way.
and
So now it's 0.3, right? Now goes. Yes, two opposite. Yeah. Yes. It's an example.
Companies, I write down some formulas for you. Let's say for question 3, you better know power equals to energy over time. And of course, make sure you know your units. Power in watts, energy in joules, and time. Units, time. Units for time. Units for time. Yeah. Okay. Make sure your units are all correct.
You skip it.
you want to read out to me?
All right. Likewise, since this is about utilities, make sure you convert to kilowatts. All right. Make sure all your conversions are right on, spot on.
Just imagine.
We don't even need to work.
What's everything is correct.
Or
It's wrong up to you.
exams.
And it's like, no, if you want to.
And then is easy.
Bernice, make sure for question 1, you use your power formula.
Oh. That's
We
good.
want,
Oh, yeah.
we want progress.
Yes. But actually not. But yes, still counts. Yeah, I feel the same. But
What can you know?
I'll wait for this now. Let's do a bigger one. Oh, which we now try friends. More difficult.
And
Why not connected? Okay, thank you.
what can you what's this?
Very good.
What's this?
Wow. Oh, this one is different.
Which is like,
I'll go through it together with. This one is not. Oh, wait, this one is lines. Oh, it's you.
yeah, I lost the thing.
Number 6 is a power formula as well. Power equals to How is power related to voltage?
It's okay.
Okay, wait.
If you continue to wait, right? Okay, you wait.
What?
You don't try.
I think something bigger.
No, it's right. I don't want remainder, so you solve until there's nothing.
Like,
Remember, there's remainder. I don't remainder. So just keep doing.
there's something.
Number one.
There we go.
How do I do it? Somehow it's just small.
Wait, what up?
Do working of small down.
Working. It takes so long.
Oh, oh, shit. I was but some no need to. If I how does that like do religion?
I think is see how to do. Wait, I don't know how. I don't know how.
Then you got one, right?
Yeah.
I thought you were like why should we yell? Be careful now. No, right? No, we cannot. How do you want to carry on?
I don't know.
There's nothing here, right? To bring on the imagination.
Imagination.
Yes, imaginary zero. Yeah, I go on really now.
Only two things I see.
When you put down imaginary number, I just put top. You to look at you and will
What?
do is one. Then when the way you go to this thing. What do you do?
Wait, why not? What you did last time? What you did last time?
And race.
Just not like numbers. Yeah, only we have to go correct. You should put the two, huh? I just don't need it. You know the answer then? I don't.
It's allowed to use. Hey, wait. I will. I'll be even on difficult.
Yeah, yay!
Let's see
I
how.
learned.
Let's see how close you
So
get.
easy.
Okay, no worries. Thank you for all that. Yeah, it's the fact then we you say it's easy, but it's not easy. You can solve, then you can
So hard.
then we
If you get very long.
it's not.
It's
Only never one is the and answer is too long.
well. If you never put the because my talking about
Wait.
I never check.
How do you do things? Oh, second CV remainder. I mean, replace one and then. Oh, already? You know,
Bro, your computer is small.
you know, you want.
Your computer is very low. Stupid people. How many numbers?
Because
Seven numbers.
just show me the first one.
And
How do you solve? Show me the next step. You can do things that you can solve again. You can't, right? You put a lot. Let's say you're reasonable, right? Just be more. How you do the now, so you know,
So I want you to tell your answer.
you can believe it's real. See there's a pattern.
Oh my God.
And here, so you see it.
18, 20, 18, 20.
So the answer that is six. So if you
That's so long.
not so much.
That's not Okay, later something faster than that. You can get it. Oh, what thing is cooking on last week?
All the way. Go lines.
Oh, yeah, balance.
Go lines. 3 days.
What is?
有一个
Okay.
What? Yeah.
What?
What do you got? What else you do?
You know what happened to your head when you go to buy milk?
Bernice?
Okay, then I'll use line. I'll really quick so you guys can see. We are learning the life of Stephen Tree.
You know why that wouldn't come from my milk? Or keyword for the best milk. And the best milk is my milk. It's like we need to travel to go on. It's not like we have to travel there. So yours is probably there.
Okay. Let me use this.
Oh, everybody don't know. You can feed basically, okay, I will draw a very simple humor. Okay, that's it. I'll give a very, the real life example.
Yes.
So what they
Okay.
can do, you really between. It's the answer here. And what you see on the.
Right, electric heater, you're given current, you're given voltage,
Yeah, you see itself, so you see another.
and you are asked for time,
Yeah.
and then you're given energy. Right, make sure you can recognize this is energy. Yeah.
That's what it is. I draw your favorite.
Okay, so you're given energy here.
Then what you see there.
Yeah, so basically you'll be using this formula and that formula. Pick one. What's your answer? A. Yeah.
Just ignore my phone. And what if I want this? Oh, this is interesting. What if
Again, make sure your units are all consistent. Current in ampere, voltage in V, volts, and of course, as I mentioned just now, energy in joules and time in seconds. So essentially, you're only using this formula and this formula. And of course, you want to solve the time.
amazing knowledge?
Right, but this you have to try it out later.
Solid. I use your.
Right, number two, everyone should get it right. Yeah, Bernice was answer number 2.
What if I want to time a symmetry? That means I want to split it for a.
You have, what do you have? You have a switch, make sure you recognize. You have a fuse, you have live, you have neutral, and you have an appliance here. 有一 D for dog, huh?
Mirror.
And of course, I think I stressed just now, look at your line.
Don't do that.
Your fuse is here. Your switch is also in series. You notice this, both of this should be in series. I mean, make sure you can recognize it. They're in series on the live wire.
How would you like to cut it up?
Yeah, okay. So check that.
Oh, yes.
Okay, Bernice.
How would it be?
Fuse and switch must be on the live side.
So big ups and downs all the thing. Wait. No, I'm not home with you. You prepare.
Okay. Now, of course, just now I'm drawing it a bit slightly differently.
Let me ask you.
But make sure you recognize that they still mean the same thing. You know how did I draw it just now? I was drawing like that. This is live.
I give you a restriction because
This is
you're
neutral.
more straight.
Alright, make sure you can recognize it's the same. No?
You cannot draw a straight line and tell your lines. How would you like to draw? Not like that.
Okay, this version is exactly the same as this version. I mean, just that they didn't draw the lines continuing. Okay, in your real house, this live and neutral will continue run around through your house.
It's okay, you cut into half.
Okay, number 3. How much energy does one bulb dissipate in 1 minute? So make sure you know 1 minute 60 seconds. Take one.
T, so you can
T for top,
Then what if I give you another example?
Okay,
Before you do anything.
so what's my power? 60 watts. Okay, and what's my time? Time is 1 minute. So make sure you know 1 minute 60 seconds, and then you just solve for E. Okay, finish.
Oh,
Alright, number 4, what are you given? Number 4, how much electrical energy is used by the heater alone? Okay, the thing is this. Heater and the lamp are controlled by one switch. So if I turn the lamp on, the heater is also turned on. And notice the lamp uses 1 kilowatt hour of electrical energy. Alright, so essentially, you have to find out how much time is this. Okay, so let me use this formula, even though I didn't mention it just now. Energy in kilowatts times hour, because here is in kilowatt hour. So 1. How many kilowatt is your lamp? Your lamp is here, 0.1 kilowatt.
So that's what Rachel did.
Okay, so how many hours is that? 1 divided by 0.1 is 10. So
There's 3 corners, right?
10 hours.
Then we talk on this one.
Alright, and therefore the heater is also used for 10 hours. And how much energy did the heater use? Well, same thing. I use exactly the same formula. Energy equals to kilowatt hour. Alright, look at the heater. 2 kilowatts. So I put 2 here. How many hours? Well, just now I figured out hours is 10 already. So 2 times 10. Therefore, the energy is 20. But make sure your units are in kilowatts hour. As I said, this is not SI unit. This is not joules. This is kilowatt hour. Right, so we have the answer by now. D for 20 kilowatt hour. Okay, take one. Okay.
If you can cut it in many ways, all of them are.
Denise,
Just like
you got to try. You really got to try.
reading.
Okay, what else? Look at number 5. This one better know. What should the fuse rating be for electric heater? Yep, Denise, number 5. The rating of a fuse is a safety feature. Your appliance is operating at a certain current. So should the rating be higher than the current, or the rating be lower than the actual current? Okay, let's look at it this way. What's the purpose of the fuse? The fuse is to prevent an overcurrent. Okay. So therefore, the rating of the fuse should be higher than the normal current of the appliance. So in this case, your answer should be. So if the normal current is 10 ampere, your fuse should be slightly higher, maybe 12 ampere, 13 ampere. Okay, so make sure you can follow that concept. All right, so if there's an overcurrent, the current goes too high for whatever reason, the fuse will melt. And basically, it will cut the circuit. Okay. Right, number 6. Joey. Yeah. Again, make sure you get it right, because when your voltage is doubled, it means my G becomes 2V. The square is still there. So what happens? 2 times 2 or 2 squared is 4. All right. Okay, so basically it becomes like that. All right, so it is 4 times of the initial value. Okay, so it should be quadruple. I mean, of course, I assume you know what quadruple means. Which course the most is operated from the same main supply?
Okay. Any card works.
Guys, well, I mean, for good practice, cost is dependent on what? It's dependent on energy usage. The more energy you use, the more you have to pay. It goes without saying.
I don't know how to cut.
And how do we determine? How do we measure energy usage? As I said, we don't use SI units. Instead, we use kilowatt hour. So therefore, I mean, for good practice, my suggestion is convert all this to kilowatt. So this is 5 kilowatt, 1 kilowatt, 0.5 kilowatt, 0.1 kilowatt, and of course, convert all this to hour. 1/60 hour, 1/6 hour, 1 hour, 1 day, and of course, make sure you know 1 day has how many hours. All right, so simply I times the two, kilowatt times hour, kilowatt times hour, kilowatt times hour, kilowatt times hour, and find out which option gives you the highest value. That is your energy usage for the individual option. Take one. What's the answer? Okay, yep, D for dog. You should get that. Okay, number 8. Current 4 ampere, voltage 250. Oh, by the way, 250 is the correct voltage. All your phone sockets, the normal sockets are 250 voltage. 250 volts. How long would it take to convert 400,000 joules of electrical energy? Of course, make sure you know, in this case, it's converted to heat energy. Joey, your answer? Okay. Okay. How do you work this? Make sure you recognize I have current and voltage. Immediately use your power formula. E equals to IV. And since I have my energy in joules, make sure you use your power formula as well. The other power formula. P equals to E/T. And from here, you solve for T. And of course, you get 400 seconds. And so you see, actually, it's the same formula all over again. All right, next one. Number 9. How much energy is converted into heat? You are given resistance, you are given current, you are given time. What formula to use? Never mind, I'll ask you for the answer. Take one. Yeah. Yeah. Okay, come guys. Right. What formula should you be using? You know resistance, you know current, and that is your power formula. P equals to I squared. I is 2. 2 squared is 4. 4 times 5, it gives you 20. Oh, sorry, 4 times, 4 times 5. When I wrote wrong. That will give you 20 units. What are the SI units for power? Make sure you remember it's watts. And then you're given time and you're asked for energy. So ask yourself, what formula relates time and energy? This one. All right, power formula again. E over T. All right, power is 20. Energy is what you want to calculate. Time is 10. So E equals to 200. Okay, so yeah, next time make sure you have a list of formulas. You can't keep them in your head. I mean, of course, in the exam you have to remember them. Okay, 1 kilowatt hour electrical energy cost 12 cents. For how long is a 40 watt lamp used if the cost is 0.24 0.24 cents. I mean, sorry, $0.24. So same thing, energy equals to kilowatt times hour.
Equal. Hey, no one.
Okay, so energy kilowatt. How many kilowatts is this? 40 watts is 0.04 kilowatts.
How do you find the area? What's this?
Okay, number of hours, I do not know. But there's this other formula, force is equals to energy times
What?
your rate. Right, energy is above. Okay, from here, you transfer over here, times your rate. What's your rate? 12 cents. Okay, and what's your cost? Cost is given as well. Cost is 24 cents. All right, so immediately you can find out this is 2.04 H. Find out what is H number of hours. So it's basically 2 divided by 0.04. And you should have your answer. Okay, with your D, 50 hours. 50 hours.
Yeah. It's the area of.
Okay, okay.
Area.
Okay, look at number 11.
Area.
Come. Let's try thinking through this one. The fuse has a rating of 3 ampere. So which statement is correct?
What? You eat. CN1. Go. So how do you make it?
What's the purpose of the fuse?
And what do you
Yeah. Yeah. Okay. Basically, the fuse is to prevent an overcurrent. If the current becomes too high, it would
How do you find?
fuse, it will melt and basically cut the circuit or open the circuit.
Ah.
Oh, just a note, huh? I mean, I didn't mention this, but electromagnet,
Then why you say that?
this is in a circuit breaker.
Okay, wait. Wait, is it?
I mean, this doesn't come up often, but occasionally you see that. A circuit breaker contains an electromagnet. A fuse does not.
So from here to here, how many?
Is the fuse connected to the earth pin of the plug? No, never. It's always connected to the live pin or the live wire.
Yeah.
All right, make sure you really burn that into your mind. Right, fuse is not to control the current. No.
Yeah.
Okay, this is quite interesting. 3 identical bulbs, copper wire connected between S and T. So basically, I have a copper wire S to T. Interesting. Copper wire. Which statement is correct, Joey?
Unique.
R goes out and P and Q get brighter. No. This one is very tricky. Try to get it right.
How much is one?
No. They already stress copper wire. Copper wire is a good conductor. By the way, most of the wires around your house are made of copper. Most of them, not all.
1 kilo.
Because it's a good conductor.
How much is one? Hey. How much together?
The only better conductor is gold, but gold is too expensive to be used too much. So what does that mean? Good conductor means it's as good as zero resistance.
You know what? 8 bottles. Okay, perimeter only the two. Only area the two. Yeah, I'll move for rectangle.
Okay, look at all your questions. Have they ever mentioned how much resistance there is in the wires? Never. Because you assume the wires have zero resistance. Can I? Okay, now what does that mean? It means my current goes through straight here. to complete the circuit, it current goes straight through and goes one round back here. In other words, try to catch this concept. The current does not go through here anymore. It does not go through here anymore. In this case, half of this resistance or half of zero resistance. Okay, current entirely goes through. Try to remember this concept. It occasionally comes up. Now, if there's a path with zero resistance, why should it go through anything else? It just goes straight through that particular path. So take note, Q and R have no current at all. They won't light up. So of course, the new current will be higher and therefore P becomes brighter. Guys, I don't know whether I said this before. Again, you're no longer in primary school. Brightness increases as current increases.
Actually, right.
That is how you check for brightness. Unlike in primary school, you don't really have a good idea of it. But brightness depends on current. As long as it's not too high. Okay, if it's too high, it will just damage your appliance. Okay, yep, yes. Bernice, any question or anyone else? No?
Then why?
Okay.
Why does
This one?
why do you draw the ornament?
Yeah, Shivendra, I didn't ask you. Do you have any question? No.
No. No.
Anything? I can't hear you just now.
No.
Okay, then I go on. Okay, this one. Yes. State in what way the mains plug has been wired wrongly. Okay, why?
Why should you ground?
Good. The live wire should be ground. Anything else? The neutral wire should be blue. Okay, good. Actually, okay, let me see.
Actually,
Let me try to rephrase your answer.
exactly like the
Because the blue is your neutral,
same.
brown is your line.
Right.
So in other words, maybe you should rephrase your answer a bit. So brown wire should
So it's not gonna
connect to L terminal.
It's very it's very let's say power you can't diagonally right.
Okay, because brown wire is
This side.
okay. I won't say any further, but you can also now they did mention way rather than ways. So by right, if you just give one way, that suffice to get you your 1 mark. But anyway, just to make sure everyone is clear, the blue wire should connect to the neutral terminal. Now, why can it cause a hazard even when the switch on the toaster is switched off? Yep, why? How do you answer this? Okay, this is a model answer to this thing. Now, remember, even though they didn't show the switch here, typically the switch is where? It's on the L side, right?
Oh, one. Oh, you see the whole
But of course, you do not need to write this in the answer.
Now we just take a very big.
Yeah.
It's funny.
Because they are asking for the hazard, not so much as in a direct explanation. Okay, the reason is this. Even if the switch is off,
We got line, right? We got like a line, right?
Right.
the toaster, in this case, toaster is the appliance, it's still
It's like.
live. This is a big problem. As
And why you do this, huh? Why are you so funny? That's funny.
the live wire, which is the brown one,
I don't.
Wait. Why do you pump the middle line?
is still
Oh,
No, does it equal?
connected.
See the same?
yes.
What?
Yeah. It's not the same.
Yeah, it's not the same.
It must be going on from.
Yeah, you don't like it.
I'm here.
Why me so funny?
Okay, there's no break in the live wire at all, because you're wired the plug only.
What? You want to see my phone? You want to get you don't put funny.
I can put all your left.
Okay, let's go on.
Thank you, this one. Thank you for me.
Input is 6 watts energy. Okay.
Yeah, it's one time.
When the battery needs to be charged, it's given a charge for 12,000 coulomb by passing a current. Calculate the time. Come, guys, what formula should you use? Bernice, what formula should you use? You know the charge, you know the current. What formula is this? I equals to
Oh,
Q
Oh.
over
Wait.
I know my turn.
Hey, look. What is this?
What the hell?
What the?
Now be careful. Coulomb is SI unit, but ampere is not. Guys, don't make this kind of small mistake. Convert to ampere. So this is 0.6 ampere, and then this of course goes into your formula. Right. Joey, what time do you get?
Oh my.
How many seconds?
Yeah.
20,000. I can't remember. Let me see. It should be quite high. Yeah. It's here. It should be.
Wow.
Yeah, 20,000 seconds. Now check your answer. It requires the answer to be in seconds, which is fine. SI units. All right, because if you use this formula, the time will automatically be in seconds. Okay, charge mixture is always in coulombs. Total energy input to the radio. Calculate the time for which the radio will operate. So, Joey, what formula would you use here? Okay, power formula, P equals to energy over time. Well, power is not here, but power is here. I hope you look further around for the hints. So this is your power. CAD units, make sure it's SI units. What? Energy. Check your units. Joules. So go straight in here. Then just find out what is time. Your answer, Joey? 12,000. Okay, yes, 12,000. All right, you should get 12,000 seconds, and seconds is SI units, so there's no need for further conversion. Okay. Questions, anyone? Bernice, I think you really need to go back and try them. Oh, I mean, okay, you can ask me after this if you want to. Okay, now, Dick, anything to ask? No. Let me see. Anything else I need to tell you? Essentially, I've gone through all this. Anything I missed out? Okay, let me just reiterate, especially that one here, this question. Because I noticed this question has come up.
So usually you just bring up the remainder streams. But right now I can put the top.
This one.
It is remainder.
Always look out for things like this. So let's say I have a circuit.
So now 4 at the table will be the category of 4.
You never use that.
Alright, looks fine, huh? And then what if you join a line across here? A wire, I mean, across here. What will happen? Now, occasionally this has come up before. Remember, a wire has zero resistance.
So now,
Okay, zero. So basically, the whole current is just flow through the wire. Therefore, there's no current through this branch. Okay, there's no current through here at all. So of course, this will not light up.
Okay.
That's not all. What else? Now look at my circuit. Where is my circuit now? It's here, no? What's the resistance in the circuit? Zero, huh? Zero, huh? What's my current then? Remember this good old formula? Look at this formula. If my resistance is zero, what is my current? My current is infinite current. All right, infinite current, no? So therefore, this is actually a short circuit. This is what they call short circuit. What will happen? Well, if you're lucky, all right, then no, I shouldn't use that. More likely than not. Okay, your battery is in this one. Right. And probably you can't repair it. I mean, you don't really have to know this, but nothing good will come out of it. And so just take note of this kind of cases. Right. Once in a blue moon, they may just come up with a question like that. But let's just say if I have something here.
Yes.
Okay, then in this case, it's still not too bad because the resistance there is still resistance. Okay, I hope you notice where is the circuit running in this case. Now my circuit is running here. All right, so at least I still have resistance, let's say 3 ohms. Okay, so I still have the current. It won't be infinite. So in this case, it's still not too bad. All right, but of course, if the current is still high, it can still damage your appliance. Okay, I think that's about it to cover for today. Any final questions? All right, so yeah, then that's all.
in one.
Okay. Shivendra, any final questions?
No, it's not the part.
Okay.
It's not the-
Shivendra? Okay, if not, I'll end the meeting now.